Good day, students. Good day, teachers. Good day, parents. Good day, friends. You're welcome to mathematics class with Miss Dairo. Our topic for today is LCM. LCM. LCM is an acronym that stands for Least Common Multiple. Welcome to class. Now today we are going to be looking at understanding LCM, where we are going to be learning about multiples, common multiples, and then LCM. Now, furthermore, we are going to be looking at three different ways we can find our LCM, which is the prime factorization method, the repeated division method, and the most interesting of all, the inspection method. At the end of today's class, you would be able to define terms relating to LCM and solve questions on LCM using three different methods. To understand and solve questions on LCM, we need to understand certain terms that makes up LCM. Multiple. The product of two given numbers is called multiples. Multiples is the result of multiplying any number with other numbers. That is, when we have 2 multiplied by 3 equals 6. 6 is a multiple of 2 and 3. Because 2 and 3 can divide 6 without remainder. So 6 is a multiple of 2 and 3. Example, we have multiples of 2, which is 2, we have 4, we have 6, we have 8, we have 12, 10, we have 12, and so on. Multiples of 3, we have 3, 6, 9, 12, 15, 18, 21, and so on. Now, those are the numbers that 2 can divide without remainder, and those are the numbers that 3 can divide without remainder. We move to common multiple. Common multiple means a number that is multiple of 2 or more numbers. Example, we looked at our multiples of 2 and then multiples of 3. So the common multiples of 2 and 3 are 6, 12, and 18. You can see if you check the multiples of 2 and 3, 6 is common in both, 12 is common in both, and 18 is also common in both. So that is why there are common multiples for 2 and 3. Now, least common multiple. Least common multiple is the smallest number that is a multiple of all the given numbers. Meaning, after writing your multiples and writing the common multiples, then out of the common multiples, you look for the least of the common multiples, the smallest of the common multiples, and that is your LCM. So if you are a beginner and you want to look for your LCM, you can consider using this method. You list out the multiples of the given numbers, list out their common multiples, and then you find the least common multiples of the given numbers. Now let's look at the first method, which is prime factorization method. Step 1. Find out the prime factors of the given number. Find the prime factors separately. Now note, prime numbers are numbers that are divisible by 1 and itself. Examples are 2, 3, 5. Now these are the numbers we are going to be using in dividing. No, we are going to be dividing with prime numbers only to find our prime factors. So these are the numbers we are going to be using to divide. Step 2. Pair same numbers in twos and leave the ones that can be paired. Step 3. Bring out one number each from the paired numbers and include the ones that weren't paired. And step 4, multiply the outcomes. So we are going to be looking at a video where we are going to find the LCM of a number of given numbers using prime factorization method. Now remember, we are going to be dividing separately using prime numbers. And we are going to use prime numbers that can divide into the given number without remainder. Now before then, let's look at this divisibility rules that is going to help us in dividing quickly. A number is divisible by 2 if it is even. or ends with an even number. So when you have a number that ends with, it's obvious to start thinking, can 2 divide this, can 3 divide this? When you have a number that ends with an even number, just know that it is divisible by 2, sorry. A number is divisible by 3 if the sum of its digits is divisible by 3. So when you have a given number and you want to know if it is divisible by 3, just add the numbers together. Here we have 321. When we add 3 plus 2 plus 1, it gives us 6. And 6 is divisible by 3, meaning 321 can be divided by 3. A number is divisible by 5 if the last digit is 0 or 5. So when you have a given number whose last digit is 5 or 0, just know that it is divisible by 5. Now I'm only going to be taking the prime numbers only. A number is divisible by 7 if you double the last digit, subtract from the remaining number, and get 0 or a multiple of 7. We have 637 here. To know if it is divisible by 7, we'll multiply the last digit, which is 7, by 2, which gives us 14. Then we'll say 63 minus 14, which gives us 49. Now, since 49 is divisible by 7, that means 637 is divisible by 7. A number is divisible by 11 if you subtract the last digit from the remaining number and get a multiple of 11. We have 297. The last digit is 7. When we subtract 7 from 29, it gives us 22, which is divisible by 11. So that means our 297 is divisible by 11. Now to the first example, find the LCM of 36 and 52 using prime factorization method. So we are going to find the smallest prime number that will divide into any of the numbers without remainder. So please note, we are to divide using only prime numbers. Now 2 is the smallest prime number that can go in 36. So 2 goes into 36 18 times. 2 into 18, 9. 3 into 9, 3. 3 goes into 3, 1. Now the smallest prime number that can go in 52, we have 2. 2 goes into 52, 26. 2 goes into 26, 13. 13 goes into 13, 1. So now we've gotten the prime factors of both numbers. Now we write them out. Prime factors of 36, we have 2 multiplied by 2, multiplied by 3, multiplied by 3. Then prime factors of 52, we have 2 multiplied by 2, multiplied by 13. Now we pair similar numbers up. So we have our 2, we pair it with the 2 down. 2, we pair it up again. Now when we are going to multiply the paired numbers, we'll use one of the numbers in the pair to represent the paired numbers. So we have 2 multiplied by 2, multiplied by 3, multiplied by 3, and multiplied by 13. So when we multiply them together, it will give us 468. And that is all for prime factorization method. Repeated division method. Our repeated division method is a bit similar to the prime factorization method, because here too we are going to be dividing using prime numbers that can divide the given numbers without remainder. The only difference is here we are going to be dividing the numbers together and not separately. Step 1, find out the prime factors of the numbers given. Then step 2, multiply the outcomes. Now to our second example, we have to find the LCM of 8, 16, and 42 using the repeated division method. Now, similar to the prime factorization method, we are also going to be dividing using the smallest prime numbers that will divide into any of the numbers without remainder. The only difference is that here we are going to be dividing the numbers together. Now 2 is the smallest prime number that can go in this number. So we have 2 goes into 8, 4 times, 2 goes into 16 8 times, 2 goes into 42 21 times. Now the next smallest prime number that can go is 2 again. 2 goes into 4 2 times, 2 goes into 8 4 times, and 2 cannot go into 21 without remainder, so put at 21. We have our 2 again. 2 goes into 2 1 times, 2 goes into 4 2 times, and we still have our 21 because 2 cannot go into 21 without remainder. 2 goes into 1 1, 2 goes into 2 1, and we have our 21 again. Now the next smallest prime number that I can divide is 3. 3 goes into 1 1, 3 goes into 1, and 3 goes into 21 7. The next prime number that I can divide is 7. 7 goes into 1 1, 7 goes into 1 1, and 7 goes into 7 1. And so we have 1 as the final answer for all of them. So write out our prime factors. 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 3 and multiplied by 7. So we have the LCM of 8, 16 and 42 equals, we multiply the numbers we have up, and we have 336. And that is all for our repeated division method. Inspection method. This is the use of intuition in finding the LCM. You inspect the numbers and apply some rules. So you just look at the numbers. There's no need to go through the long calculation. You just look at the numbers, you inspect them, and you get your LCM. This is the quickest method for finding LCM. Now we have to find the LCM of the following numbers using the inspection method. Now LCM of 5 and 25. Since 5 can go into 25 without remainder, so the LCM of 5 and 25 equals 25. Now 2, we have LCM of 10 and 25. 10 cannot go into 25 without remainder. So we multiply our 25 by 2, which is 50. So since 10 can go into 50 without remainder, our LCM is 50. Now we have LCM of 9, 12 and 18. 9 can go into 18 without remainder, but 12 cannot go into 18 without remainder. So multiply our 18 by 2, which will give us 36. So since 12 can go into 36 without remainder, our LCM is 36. Now we have LCM of 11 and 16. So 11 is a prime number. All what we just need to do is to say 11 multiplied by 16, which will give us 176. Now LCM of 2, 9, 13 and 18. 2 can go into 18 without remainder. 9 can go into 18 without remainder, but 13 cannot go into 18 without remainder. So since 13 is a prime number, we say 13 multiplied by 18, and it will give us 234, which is our LCM. Now, class drill. Question 1. Find the LCM of 24 and 36 using prime factorization method. Question 2. Find the LCM of 8, 14 and 24 using repeated division method. Question 3. Find the LCM of the following using inspection method. And we're done for the day. Now send your answers to the numbers showing on your screen. The answers to your class drill, send them to the WhatsApp number showing on your screen. Now don't forget to subscribe to this YouTube channel, like the video, and leave a comment. Thank you for learning today. Till we meet next time, stay safe and have fun learning. Bye.